All right, well, I'd like to start things off by saying welcome and thank you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the Fischertechnik Education Division over here at Studica. And today I'm going to provide you with a little bit of an overview of Fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in CTE training, if you're a college professor or industrial trainer teaching programming skills required in manufacturing, if you were involved with a company looking for ways to demonstrate their software-based solutions, or even if you're just someone looking for ways to make IoT-related concepts easier to understand to employees and to customers, I believe this presentation is going to offer some important options for you to consider. Now, let's start off by considering the skills gap. Now, if you've attended any of our other Fischertechnik education webinars, you've probably heard me discuss the importance of STEM education, STEM, of course, being an acronym which stands for Science, Technology, Engineering, and Mathematics. And it should go without saying that STEM education has been perhaps the most discussed topic in education over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help them best prepare themselves to take their place in the modern workforce. Now, not so long ago, when our parents or even our grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. Now, as it ties in directly with the solutions that we're going to be looking at in this presentation, let's just consider that last skill area that I just touched upon, that being a PLC programmer. Now, first off, for anyone who may not be familiar, let me explain exactly what a PLC is. The term PLC is an acronym, the letters of which stand for Programmable Logic Controller. And essentially, a programmable logic controller, or PLC, is a very specialized computer which is used to control the types of machines and automated processes typically found in an industrial setting, such as, for example, an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. And to get a clear idea of just how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programmer salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. Now, as I prepared this webinar, which was early last year, I took a look at the list of current job openings for PLC programmers at that time. And the listings back then showed 15 positions being advertised with salaries of over $75,000, and 2 of which even listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and the university level. And at the same time as this is going on, as this workforce of tomorrow is seeking their own training, more and more manufacturing companies who are facing an urgent need right now are enrolling their incumbent workers into private training schools offering such programs. Now, how long does it take to learn PLC skills? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. But of course, to become truly proficient in all 5 of the most widely used PLC programming languages, which you see listed on the screen right now, as well as really learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, more training would be required. So where do you go? Well, once again, while many students can learn PLC programming skills in a college lab setting, there are, of course, many other options available. There's high school CTE, career technical training programs. There's adult continuing education programs, vocational training, technical training and trade schools, and also employer-sponsored incumbent worker training programs, which I just touched upon. Now, that all being said, the question that still arises for the educator, and and that's whether you're an educator in the university or the vocational school classroom, is how do you go about teaching PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it more realistic and hands-on? But of course, there are other areas to focus on beyond programming that need solutions for demonstrating and exploring and understanding different aspects of automation and control systems. Now, it could be, for example, a company involved in creating or manufacturing a new type of software-based solution that's looking for ways to make more tangible processes which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturer looking for better ways to visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's a company looking for an engaging way to demonstrate their services or solutions in a public setting, such as a trade show. Now, in each of these cases, and of course there are more, there's a need to find solutions that are engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of fischertechnik industrial simulation and training models. Now, these models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate in both appearance and function various automated and robotic machines and systems commonly used in commercial manufacturing. But before we look at each of these models, let me provide you with just a little bit of background. Fischertechnik has been creating tools for teaching students of all ages about how technology works for over 50 years, all of which is based around their unique building system. Now, what makes the Fischertechnik building system unique is that unlike other popular construction systems where the components are designed to simply stack, with the Fischertechnik system, it was created with more of an engineering mindset. The core building block used in the system is designed to enable attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different parts available will also help to address very specific design needs. The Fischertechnik system was created back in the 1960s by German inventor Arthur Fischer, who you see on the screen now, who's noted for countless innovations used in the construction and the automotive industries. Now, Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, and that was back in 1949. And he was also the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. I'm sure we've all used them. Now, his company, the Fischer Group, employs thousands of individuals worldwide, producing many variations of the fastening devices used in building construction. And they also produce numerous components used in automobile assembly, as well as in providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Once again, the focus of Fischertechnik sets, jumped ahead there, whether those intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology. Many of the products offered by Fischertechnik for the education sector are subject-specific sets, focusing on different STEM-related skills such as mechanics, pneumatics, robotics, or renewable energy. Now, in many of these sets, students are asked to build a progression of models using the unique Fischertechnik building system, and then afterwards perform a series of experiments which allow them to explore and understand different aspects of that subject being explored. Now, there are also sets designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based programs, students can dive deep into engineering and learning all aspects of the design process, which requires them to work in groups and to create various devices and automated machines to meet the criteria being put forth in a series of real-world style scenarios based upon their own trial and error experimentation and research. Now, the line of Fischertechnik simulation solutions, which of course are the focus of today's presentation, are something much different. This line consists not of kits, but of a series of pre-assembled small-scale models which replicate in appearance and function various automated robotic machines and systems. Models in the fischertechnik simulation line include conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, fischertechnik also offers an integrated factory simulation model. This model consists of 4 individual workstations, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with oven, and a sorting line with color detection, all of which work together as one self-contained material cycle. Before we begin to look at the models in the simulation line in more detail, let me briefly outline some of the advantages of using fischertechnik solutions. I apologize in advance, as the first few points are things I've touched upon before, but I think in each case it's worth repeating. First, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in the programming of the PLC-focused learning environment. The models, once again, are designed to realistically replicate, in both appearance and in function, common automated systems such as conveyor belts, sorting machines, robotic arms, and many more. Because the models are compact, and in most cases tabletop size, they are not only ideal for use in the classroom or in office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. Next up is quality. Each fischertechnik simulation model is a hand-assembled, high-quality German-made product. Each of these models is available in a 24-volt version designed for use with industry-standard PLCs. Now, it doesn't matter whether you use Allen Bradley controllers, if you use Siemens controllers, or even if you use controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, and of course many others we could probably all name. You can control these 24-volt fischertechnik models with the PLC of your choice. Likewise, just as you can use your choice of controller, you can also use your preferred programming language. So if you're more comfortable with ladder diagram, or if you have more of a need for sequential function charts, function block diagrams, structured text, or instructional list, you can use whichever one you prefer. Now, please note that with these 24-volt versions, no PLC is included, and all programming and all programming guidance, as well as any power sources or other hardware, are the responsibility of the end user. Of course, this shouldn't be an issue, as these models are designed specifically for industrial users or for those individuals teaching or exploring industrial processes involving PLC programming. But in addition, for non-industrial users and for educators not versed in or familiar with PLC programming, there are also several models which are available in 9-volt variations. These 9-volt versions will ship pre-wired to fischertechnik's own proprietary robotic controllers, which are called the Robotics TXT controller. And each of these controllers is pre-programmed using fischertechnik's own RoboPro programming software. The only additional component required with these 9-volt versions will be the addition of one or more 120-volt power adapters, as specified with each model. As these come up in the discussion, I'll tell you how many of these how many power adapters you would need. Otherwise, in most cases, these models should be ready to use right out of the box. Moving right along, if you're involved in demonstrating or exploring IoT, which of course is also known as the Internet of Things, besides the fact that many end users have already adapted many of the models in the primary line of simulation and training solutions for IoT purposes, fischertechnik now also offers a special IoT-focused version of the factory simulation, which is designed specifically for exploring and understanding cloud control in what is sometimes referred to as Factory 4.0. Now, in this case, the model is designed to be both controlled and monitored from a special web-based dashboard. And we, of course, will discuss this in more detail when we get to that in the presentation. Finally, fischertechnik simulation models are designed to be cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation solutions which are available in the marketplace, You've probably noticed that the entry point for many of these products can easily be $20,000 to $30,000 or even a lot more. Fischer-Technic simulation solutions, on the other hand, are available at just a fraction of that price, as well as, again, being compact, realistic, and high-quality learning and demonstration tools. So on that note, I'm going to grab a sip of water, and then we're going to take a look at each of these models, which are available. The first model we are going to look at is the vacuum gripper robot. Now, as you're going to see in a second, the vacuum gripper robot is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component that you see on the arm of the model in the video, and it includes a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches and has a weight of about 7 pounds. The 24-volt versions of this model, as well as all of the first 5 24-volt models we will look at today, each have a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as well as all 24-volt versions, will require you to provide the PLC and the programming. And for a limited time, there is a 9-volt version available, which is the version you see in this video. And once again, this will come pre-wired to the Fischer-Technic Robotics TXT controller and will ship fully programmed using RoboPro programming software. Now, if you wish to create your own programming, individual licenses of RoboPro are available on our website. Otherwise, for this 9-volt version, only the addition of a single 120-volt power adapter will be required. I will mention that for this and for all the models we're going to look at today, the specs are also detailed in the products listing found on the Studica webpage, as well as in the product brochure, which I will provide information on obtaining at the end of this presentation. Next up, we will look at the automated high bay warehouse. The model you're going to see here features a transfer station with conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, as well as 9 individual storage spots. Components of this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each piece. I will mention that this particular model is a favorite among educators I've spoken with who teach programming because it gives you a lot to work with. Now that's because of in regards to the movement of the picker mechanism, as well as the precision required to properly store and retrieve each piece, each step, which will of course require its own very specific programming. The dimensions for this model are approximately 19 by 28.5 by 15 inches, and it has a weight of approximately 18 pounds. Again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector with 34 pins and a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. And again, you will need to provide your own PLC and programming. And in this case, a limited edition 9-volt version is available at this time for a very limited time, which again comes pre-wired to a pre-programmed TXT controller, and one 120-volt power adapter is required for that model. Next up is the multi-processing station with oven simulation. This model features a furnace simulation with a pneumatic sliding door, which you're going to see in just a second here. There is a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches and has a weight of about 11 pounds. Again, the standard version of this model is a 24-volt version for use with the PLC of your choice with, once again, a relay board for motor polarity reversal and both a multi-pin connector with 34 pins and a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. And again, the limited edition 9-volt version is available. In this case, it is connected to 2 robotics TXT controllers. And because of this, 2 120-volt power adapters will be required for all operations. We'll just let this play out another second. So next up in our progression is the sorting line with color detection. Whoop. Let me just mute these guys here. You don't need that. This simulation model features a system for detecting work pieces of different colors, and it sorts them via a conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of about 10 pounds. Now, as with the models we've looked at before, the standard 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as an additional PCB terminals with pushing connections for all inputs and outputs. And again, you need to provide the PLC and the programming. There is a 9-volt version available this year. Again, comes pre-wired to a pre-programmed TXT controller, and 1 120-volt power adapter is required with that. Now, I will mention with any of these where I do mention the 9-volt versions, they are in very limited supply by and large, with the exception of a few models that will continue to be manufactured in 9-volt versions. Otherwise, really the focus is on the 24. The next model is the factory simulation, and this combines the 4 models we've just reviewed: the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection. It combines all 4 of these models into one self-contained material cycle. And the cycle you're going to see works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then moved to the multi-processing station with the oven. After the work piece has been processed by this machine, it is then sorted by color in the sorting line with color detection before being again moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've already discussed the components of each model previously, I won't belabor it by restating them here, but what I do want to discuss are the dimensions of this model as a whole. As it again combines 4 individual work models into one cycle, it has a much larger footprint of approximately 39 by 31 by 16 inches, and it has a weight of between 43 and 46 pounds, depending on whether we were talking about the 24-volt version or the limited edition 9-volt version. Now, due to these dimensions, please note that this model will only be shipped flat as freight on a pallet. And I also want to point out that as the factory simulation models tend to be in very high demand, at times you have to anticipate a turnaround time of up to 2 to 3 weeks prior to any orders for this model leaving our warehouse. A few other things to note. First, this is again currently available in the standard 24-volt version, and in very limited quantities, it's available in a 9-volt version. Now, in the case of the 9-volt version, it is wired to 5 robotics TXT controllers, and because of this, it will require 3 120-volt power adapters. Now, as always, the 24-volt version will require the end user to provide both the PLCs and the programming, as well as any other hardware required. Again, each station of the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the two factory simulations which we just looked at, as well as a couple models we're going to see down in a little further down in the presentation. So for anyone who might need to transport the model or just wants protected when not in use, this is something to consider. It's the travel case. The travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion of the case is lined with hard foam. It's designed so that once the top portion of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case itself has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of about 53 pounds, 53 pounds. That's empty, that's without the factory in it. So once you put a factory in one of these, depending on which factory model we're talking about, you could be talking about 100 to 110 pounds total. Please do note that even when using the travel case, these models will still need to be shipped flat. So even though we have that travel case standing on its side, you would normally put it flat long ways. Anyway, moving right along, the next model is a basic conveyor belt. And this is a transport belt with a length of 275 millimeters that is used to transport work pieces with a dimension of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as you may desire. Components on this model include an excess motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 14 by 10 by 4 inches, and it has a weight of just under 2 pounds. Now, as before, the standard 24-volt variation includes a multi-pin connector, but in this case, it's a 26-pin connector with a 2.54 millimeter grid as seen here, and it is also available for a limited time in a 9-volt version pre-wired to the robotics TXT controller as shown here. One 120-volt power adapter is required for the operations of this model. Next model is a variation of the conveyor belt, but in this time including a punching machine. This features essentially the same conveyor as we just looked at, except that this time the machining station is built in. Components on this model include 2 excess motors, 2 push-button limit switches, 2 photo transistors, and 2 LED light barriers. Dimensions on the model are approximately 15 by 12 by 7.5 inches, and it has a weight of just around 3.5 pounds. Again, it's available in the standard 24-volt variation with a 26-pin connector, 2.54 grid, as shown here. And for a limited time, we will be offering a 9-volt version wired to the robotics TXT controller, which again requires one 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. And this model features a U-shaped conveyor line consisting of a milling and a drilling station, along with 4 conveyor belt sections. Components on this model include the 4 conveyor belts, as I just mentioned, 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions of the model are approximately 19 by 18 by 11 inches, and it has a weight of about 8 pounds. Again, it's available in both the standard 24-volt version with a 26-pin connector and 2.54 millimeter grid for use with PLC, as well as, a limited release 9-volt version wired to the pre-programmed robotics TXT controller and requiring one 120-volt power adapter. Next up is a variation on the idea of a pick-and-place robot, in this case, the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or backwards 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. Again, this model is available in either a 24-volt version with a 26-pin connector and a 2.54 millimeter grid, designed again for use with the PLC and the programming of your choice. And it is also available in a 9-volt version, which in this case is not a limited availability model. This is something that's going to continue into production. And it's once again wired to a pre-programmed robotics TXT controller and requires one 120-volt power adapter. And that concludes our look at the first 9 variations of simulation models. The next pair of models we're going to be looking at focus on the area of IoT and are designed specifically for demonstrating and teaching about cloud-based monitoring and control. These models go by the name of Training Factory Industry 4.0, and these are available in both 24-volt versions for use with PLC, of course, and 9-volt variations for classroom and demonstration purposes. Now, they've been designed to help address how the recent changes in industrial production, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. With this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a larger scale. Now, as the following video showcasing the 24-volt version provides a nicely narrated overview of just how this factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator. So just to touch on some of the points again, the following topics can be addressed with the Fischer-Technic Training Factory Industry 4.0. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, and the collection of upstream and downstream logistics processes. Now, as you just saw, the model incorporates many features not found in the models that we've previously looked at, besides just most notably the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, which enable the positions of each piece in the work cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, that allows the network TXT controllers to communicate with each other. Now, as there are two variations of this model, let's go over what makes them different, aside from the voltage requirements. We'll begin by focusing on the 24-volt version and what makes it unique. First, it's a bit of a hybrid, and in that, while requiring a PLC for operation and control, this model also incorporates one Fischer-Technic Robotics TXT controller. Now, in this case, the TXT controller serves as the MQTT broker and interface to the Fischer-Technic cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. Now, OPC UA is also known as OPC Unified Architecture, and it's a standard for exchanging data across different platforms. In addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node Red. Now, this allows the option for not only presenting and using data on a dashboard in the Fischer-Technic cloud, as we just saw with the 9-volt version, but also to be able to display data and calibrate the stations of the factory in a Node Red dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. These all, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, also known as pulse width modulation. They also have push-pull output stages for phototransistors and for buttons. Finally, one of the most important new features. Unlike any of the previous 24-volt models that we've discussed today, the new 24-volt Training Factory Industry 4.0 also includes access to a sample program. In this case, the sample program is in structured text format, ST format, and was created based upon a Siemens S7 1500 PLC and is available for download on GitHub. Of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes some small adjustments to the sample program. And if you wanted to do so, the source codes available for this are for download on GitHub. So if you want to create your own programming and you're not using the Siemens or what have you, you can just, again, download all the source code from GitHub, modify it as need be, and use it with this model. Now, as with the first of the 24-volt models we looked at today, each of the workstations of the 24-volt variation of the Training Factory Industry 4.0 model have a relay board for motor polarity reversal and both a multi-pin connector, again, the 34 pins with a grid of 2.54 millimeter variation, along with PCB terminals with pushing connections for all inputs and outputs. Now, all of this information that we've gone over here and much more is included in a 152-page PDF manual, which can be downloaded when you purchase the factory simulation, and it can also be downloaded directly from our website right now. So if you go to the Fischer-Technic website and you go to the Training Factory Industry 4.0 model, there is a place to download the complete manual so you can see all the specs. Now, moving along to the case of the 9-volt version, this is the control here is facilitated through the use of 6 robotics TXT controllers. Now, unlike all of the other 9-volt versions that we've looked at previously, these controllers are programmed not using RoboPro, but instead in this case using C, C++. Now, again, all the programming is preloaded, so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF, which for this version is also available on our website. So if you want to download it first before you put in an order and check out all the specs, you're welcome to. As long as you basically make the connections to the internet-based dashboard, once you do that, you should be able to get started quickly. The 9-volt version will require the addition of 3 120-volt power adapters for powering the TXT controllers. Of course, it requires the ability to access the internet as well as a tablet or a device for using the cloud-based dashboard. In either case, the dimensions for these models are approximately 39 by 31 by 16 inches, and they have a weight of approximately 51 to 53 pounds, depending on the version. Now, as with the first 2 factory simulation models, which we discussed previously, we do recommend the optional travel case to help protect your model during transport or, of course, during storage. And that's the Training Factory Industry 4.0 model, now available in both 9-volt and 24-volt variations. I will mention as well, we don't have it included in this presentation as of yet because they are still not available, as so many things are getting downloaded or delayed, I should say, as we're working our way out of this COVID environment. But there will soon be available a version of the 24-volt Training Factory Industry 4.0, where it is basically completely pre-wired. As anyone who works with PLCs knows, there's a lot of wiring that goes on between the PLC and the model being used or the machine being used. These models normally do not include that wiring. There is going to be a version of the Training Factory Industry 4.0, which will include all of that wiring so that you'll be able to plug the PLC directly in. Currently, that is not the case. The wiring would be required, but there will be a version with all that wiring. It is going to be a higher price. We don't have all the specs on it yet, but we're hoping that will be available in the next month or two. We'll have more information on that as well. There will also eventually be a version that not only will include the wiring, but also will include a Siemens controller, the Siemens PLC. That's going more towards essentially more plug and play type option, if that would be something you'd be looking at. The price will be higher, of course, and once again, we're going to have specs on those in the next month or two. Anyway, about the other things that we can talk about, of course, you might be wondering how much these models cost. So let's just take a quick review of each of these options discussed along with the pricing for each of the options. First up is the vacuum gripper robot. The 24-volt version with the part number you see there is $974 per unit. The 9-volt version pre-wired to the TXT controller is $11.99 per unit. The automated high bay warehouse in the 24-volt version, 536631, is $1,099 per. The 9-volt version, 536626, pre-wired to the robotics TXT controller, is $1,319. The multi-processing station with oven in the 24-volt version, 536632, is $999 per unit. The 9-volt version, number 536627, is $1,479 per unit, again, pre-wired to the robotics controllers. These are all, of course, list prices. You can get a quote from us as well. Sorting line with color detection, 24-volt version, is $836 per unit. The 9-volt version, 536628, which includes the robotics TXT controller, is $1,129 per unit. When we get to the factory simulations, the 24-volt variation, this is the regular factory simulation, not the IoT version. The regular factory simulation on a 24-volt version is $4,029. In the 9-volt version, once again, pre-wired to the robotics TXT controllers, is $5,239. The conveyor belts, the 24-volt version, 50464, is $226 per unit. A 9-volt version wired to the TXT controller is $519 per unit. The punching machines with conveyor belt in the 24-volt version, 96785, is $299 per unit. The 9-volt version, again, pre-wired to the robotics TXT controller 51663 is $599 per unit. The 3D robot in the 24-volt version 511938 is $865 each. The 9-volt version 511937 pre-wired to the pre-programmed TXT controller is $1,169 per unit. The indexed line with 2 machining stations in the 24-volt version 96790 is $869 each. The 9-volt version 51664 is $1,399 per unit. And finally, the Training Factory Industry 4.0. These are the current versions. The 24-volt version 554868, $7,896 per unit. The 9-volt version 551584, $7,560 per unit. Other items, the 120-volt power adapters for use with the 9-volt models, which I touched upon several times, are $12.99 each. And the travel and storage case, which again is designed for either of the 2 factory simulations, the regular 9-volt or 24-volt versions, as well as the Training Factory Industry 4.0 models. It's the perfect way to store and transport them. The part number is 551587. They are $1,000 each. So on that note, if you have any questions, this would be the point of the presentation where you can use the chat window, the question and answer window. Feel free to type in anything you might have. I will see if there's anything coming. Going once, going twice. All right. If you do have any questions, you can still type them in, but I will just keep things moving along. Taking the next step. If you would like to request a full color brochure and current pricing, if you'd like to ask any questions about any of these models directly, if you'd like to request a quote, or if you would like to speak with your dedicated educational representative or find out about other fischertechnik options that we have available, you can contact us. Our phone number in the US is Studica US 888-561-7521. You can email us 2 ways. General emails about any of these models or fischertechnik. You can email us at info@studica, studica.com. If you have questions about any specifics, any technical aspects of any of the models we've looked at today, something you need to know, you can email me directly. That's my email address, lance.zurek, lance.zurek @studica.com. So on that note, as I don't see any questions coming through, I'd like to thank you very much for taking the time to attend our presentation today. Again, email me with any questions you might have, any concerns, anything like that. Feel free to give us a call, and we look forward to hearing from you soon. Thank you and take care.